Alright, this video is optional. You don't need to take any notes and you don't have to watch it. This video is the proof of Kramer's rule for a 2x2 system, and I know I have a lot of videos today and it's going to be time consuming, so if you don't have time or you're not interested in seeing the proof, you can skip this video. So here's where this idea comes from. Suppose you have a 2x2 system and you're going to solve it by elimination. Notice that instead of having specific numbers in here, I just have coefficients A1, B1, and R1, A2, B2, and R2. So if we wanted to solve by elimination, we could multiply the top equation by A2 and the bottom equation by A1, and that would give us A1 A2x plus A2 B1y equals A2 R1, and A1 A2x plus A1 B2y equals A1 R2. So if we subtract these, the x terms cancel, and we're left with y times the quantity A2 B1 minus A1 B2. And that equals the quantity A2 R1 minus A1 R2. And notice that those numbers are a product of two things minus a product of two things. Those look like 2x2 determinants. First, I'm going to divide both sides by the quantity to get y by itself. So y is A2 R1 minus A1 R2 over A2 B1 minus A1 B2. And I'm actually going to multiply the numerator and denominator by -1, just because I want things to go in a particular order, and I don't have that order yet. And that gives me A1 R2 minus A2 R1 over A1 B2 minus A2 B1. And if I write that in determinant notation, the numerator is the determinant of the matrix with A1 and R2 on the main diagonal, and with A2 and R1 on the other diagonal. And then the denominator is the matrix with A1 and B2 on the main diagonal, and A2 and B1 on the other diagonal. So what you see is, to get the value of y in a 2x2 system, it actually boils down to a 2x2 determinant over a 2x2 determinant. And to get the value of x, I could do the exact same thing. Instead of eliminating x, I'm going to eliminate y. So I'm going to multiply the top equation by B2. And I'm going to multiply, oops, let me put my parentheses later. Going to multiply the second equation by B1. And the first equation is now A1 B2x plus B1 B2y equals B2 R1. The second equation is A2 B1x plus B1 B2y equals B1 R2. And if we subtract, we're going to eliminate the y terms this time. And we have x times the quantity A1 B2 minus A2 B1 equals B2 R1 minus B1 R2. And then if I divide to get x by itself, these are also 2x2 determinants. So the numerator could be thought of as R1 and B2 on the main diagonal, and R2 and B1 on the other diagonal. And then the denominator, A1 and B2 on the main diagonal, A2 and B1 on the other diagonal. So actually, if you look at x and you look at y, they have the same denominator. And the denominator is the determinant of the 2x2 matrix that is formed when you just use the coefficients on x and the coefficients on y. Now the numerator, when you're looking for x, you don't have the x coefficients here. You have the r values, the constants, in their places. And when you're looking for y, you don't have the y coefficients here, the b values. You have the r coefficients in their places. So this is known as Kramer's rule for a 2 by 2 system. So now I'm going to go on to video 3, and that one is required, and you'll do some examples using this method.